Hello everyone, I am Dr. V. Sita Lakshmi, Associate Professor, Department of ECE, KPR Institute of Engineering and Technology, Coimbatore. I am going to teach you how to plot a polar plot using MATLAB. Polar plot is a plot which can be drawn between magnitude and phase angle of g of j omega, which is nothing but a transfer function by varying omega from 0 to infinity. It is of the form g of j omega h of j omega, that is equal to magnitude of j omega h of j omega and angle of g of j omega h of j omega. So polar graph sheet consists of concentric circles and radial lines. The concentric circles represents the magnitude and radial lines represents the angles. The angles are represented by positive angle if we go in the anti-clockwise direction. For example, 0 is the reference angle. If we go upwards, which is anti-clockwise direction, the angles are positive. If we go down in the clockwise direction, the angles are negative. For example, if we go in the anti-clockwise direction, the plus 270 degree represents the minus 90 degree in clockwise direction. So this is the polar graph sheet. As I told you, it is having large of concentric circles. The concentric circle represents the magnitude, and these radial lines, these lines represents the angles. The angles are written here. This is 0 is the reference. This 10, 20, 30 are positive angles, and this 10, 20, 30, 40 are negative angles. We are going in clockwise direction, so the angles are negative. We are going in the anti-clockwise direction, the angles are negative. Magnitude is marked on the circles. How to calculate gain margin, phase margin and stability using polar plot. So before going to the gain margin and phase margin, two important terms there. One is phase crossover frequency and another is gain crossover frequency. What is the phase crossover frequency? It is a frequency where the polar plot intersects the negative real axis. This is the polar plot. So this polar plot, and this is the negative real axis, this is the positive real axis, and this is the negative real axis. The polar plot intersects at the negative real axis at this point. Okay, this point we call it as a phase crossover frequency. Gain crossover frequency is the frequency where a polar plot intersects the unit circle. So this is the unit circle. The unit circle is circle having a magnitude of 1, and this is the polar plot. Here the polar plot intersects the unit circle. This point we call it as a gain crossover frequency. So these two terms are very important in calculating gain margin and phase margin. Let us see what is phase margin. Phase margin is the amount of additional phase lag added to the gain cross frequency required to bring the system to the verge of instability. It is represented by phi m. Phi m is equal to 180 plus phi. Phi is nothing but phase angle of g of j omega. If phi m is greater than 0, then phase margin is positive and the system is stable. If phi m is less than 0, and the phase margin is negative and the system is unstable. Gain margin is the reciprocal of the magnitude of g of j omega at the frequency at which phase angle is minus 180 degree. So gm is equal to reciprocal of g of j omega c, where c is the frequency called phase crossover frequency. So this is represented by x. If you represent the gain margin in dB, the formula is 20 log 10 1 by g of j omega at phase crossover frequency. If this term goes up, you will get a negative sign, minus 20 log 10 of g of j omega at phase crossover frequency. So how to find the stability in the polar plot? So this is this point. As I told you, this is the unity circle, and this point is minus 1 plus j0. This point is critical point. If polar plot lies within the critical point, then both gain margin and phase margin are positive and the system is stable. If this polar plot crosses critical point, both gain margin and phase margin are negative and the system is said to be unstable. If the polar plot just crosses the critical point, gain margin and phase margin are 0 and the system is said to be marginally stable. So in this way we can calculate the stability of the system. So now let us draw the polar plot and find the gain margin and phase margin for the transfer function g of s is equal to 1 by s into 1 plus s whole square. So this is the open loop transfer function of a unity feedback system. So we are going to sketch the polar plot and determine the gain margin and phase margin. So at step 1 we are going to substitute equal to j omega. So this becomes j omega is equal to 1 divided by this will become j omega and this will become j omega. Okay, so you open this term like this. Why we have opened this? We have to find the magnitude and angle separately. In step 2 we are going to find out the magnitude and angle separately. So we have to find out magnitude and angle of this term. So the magnitude of this term is omega. So I have written here omega. Angle of this term is 90 degree. J means 90 degree. So omega angle 90 degree. So in order to find the magnitude angle of this term, there is a formula a square plus jb square is equal to square root of a square plus b square, that is the magnitude. Tan inverse of b by a is angle. So here this is magnitude, square root of 1 plus omega square is the magnitude. Tan inverse of omega is an angle. Similar this term also, this is the magnitude and this is angle. So now we have to separate the magnitude and angle, and omega is the magnitude and this is the magnitude and this is the magnitude. So both are same term. So square and angle 90 degrees at the denominator. If you take it at the numerator it is 90 degree, and here tan inverse of omega, if you take it to the numerator it is minus tan inverse of omega. This also if you go to numerator it is minus tan inverse of omega. So minus tan inverse of omega minus tan inverse omega is nothing but minus 2 tan inverse omega. Okay. So then magnitude of j omega, you keep this like this, you open this bracket, this is square root of 1 plus omega square whole square. So if you open this bracket you will get 1 by omega plus omega cube. Angle is written like this. Now in step 3 we will assign various values of omega because we are going to plot the graph. So for that we need so many values of omega. So we have assigned the values of omega as 0.4, 0.5 up to 1.1, and this value we are going to substitute in the magnitude. So instead of omega we are going to substitute 0.4 and calculate the magnitude. The magnitude value will be 2.2. If we substitute 0.5 in the place of omega, the magnitude becomes 0.6. Like this we are going to plot these values and calculate the magnitude value. Similarly, you substitute the value of omega as 0.4 in this angle and calculate, and this becomes minus 134, and you calculate 0.5 and the angle is minus 43. Like this you substitute the value of omega in angle term and you ask readings. Now we are going to plot these values, this magnitude values and angle in the polar plot. So this is the graph sheet. As I told you, this polar graph sheet consists of large number of concentric circles. The concentric circles represents the magnitude. First we will assign magnitude to the circles. So magnitude varies from 0.4 to 2.2. Okay. If you see in the graph sheets, there will be 5 dark circles. So we will divide this value. First circle we will assign 0.5, 1, 1.5 to 2.5 because we need a value up to 2.2. So we have assigned 0.5, 1, 1.5 to 2.5. So between two circles, between these two dark circles, totally 10 lines will be there. So 2 lines is 0.1. So this is 2. So 2.1, 2.2, 2.3, 2.4, 2.5. So between 2 lines equal to 0.1. Okay. So in this way we have marked magnitude and angles are already marked. Now I will explain you how to plot. We will go from lower value, 0.5 is the magnitude and minus 185 is the angle. So 0.4 is the magnitude. Circle, this dark circle 0.5, and before that 0.5 2 lines, that is 0.4, and angle is 185. So this is minus 180, this is minus 190. 185 is between these two. Just to go along this line and touch the point where 0.4 circle is there. So this minus 185 and 0.4 touches at this point. So this point is marked. Then 0.5 minus 180. So this is the 0.5 is the circle and minus 180 is the axis. So this is the 0.5 minus 180. Next, 0.6 minus 174. So 0.6 means from this dark circle you leave two circles, then this is the 0.6 circle and angle is minus 174. So this is 170, this is 180, 174 is between these two. Just to go along this one, where it touches 0.6 circle, you mark one point. Like this you mark all other points, okay, and you join all those, you will get a polar graph sheet. Polar graph in a polar graph sheet. So now with this polar graph, we are going to calculate gain margin and phase margin. As I already told you, the gain margin is nothing but reciprocal of G j omega at phase crossover frequency. All of you know this point is called phase crossover frequency, the point where the polar plot touches the negative real axis, that is minus 180 degree axis. So at this point, what is the magnitude? So that magnitude is 0.5. So 1 by 0.5 equal to 2, that is the gain margin. Then how to calculate the phase margin? Phase margin is nothing but 180 plus pi dc, that is phase angle at gain crossover frequency. What is the gain crossover frequency? Frequency where the graph touches the unit circle. So this is the circle with the magnitude 1. So I have darkened this circle and this is the unity circle, and graph touches the unity circle at this point. At this point, what is the phase angle? So for calculating the phase angle, join from center this point and extend like this. This dotted line indicates the point, and the angle at this point is minus 159 degrees. Okay, so phase margin is nothing but 3 degree minus 159. 5 GC is minus 159, that is 21 degree. So gain margin is 2 and phase margin is 21. And see, this is the critical point and your polar plot is inside the critical point. The system is stable system. Okay. Now I am going to plot this polar plot in the MATLAB. So these are the polar command in order to plot the graph. So I will explain you in the MATLAB. So this is the program for plotting the polar plot in the MATLAB. The first instruction is clear all. This clear all the lines, clear screen. Then S is equal to transfer function of S. So the transfer function is represented in terms of S by using this command. Now we have to display our transfer function. So this line is given. The given transfer function is, then we have written our transfer function. Our transfer function is g of s is equal to 1 by s into 1 plus s whole square. So I have written like this. So this transfer function is displayed in the command window. Then this command, this numerator polynomial and denominator polynomial is obtained from the transfer function by using this command. Now we have to assign the various values of omega. So the starting value I have assigned 0.4 and the step value is 0.01, that is 0.4, 0.41, 0.42, like this. We are going to take the scale till 4. Okay. This command separates the real part and imaginary part of this transfer function for various values of omega. So for first value of omega is 0.4, it separates the real part and imaginary part. This command calculates the gain margin and phase margin of the given transfer function. Now we have to display the gain margin and phase margin. So the gain margin is that is displayed here. Then GM gives the gain margin, which is calculated using this command. Then the phase margin is PM. PM is calculated using this command. Next command is Z is equal to RE plus I into imaginary part. So this command converts the rectangular form to polar form. Rectangular form is calculated here. That rectangular form is converted into polar form. So R is nothing but absolute value of Z. That means we are taking the magnitude of this Z as R, and angle of this polar form is theta, theta is equal to angle of z. So with this magnitude value r and the angle value theta, polar plot is plotted with the help of this command. So these are the instructions, these are the code for drawing the polar plot. Now I am going to run the plot. I will go to editor and I click the run button. Now see here in command window, the first given the transfer function is displayed. The gain margin is calculated as 2 and phase margin is calculated as 21.387. So the same gain margin and phase margin we got using our calculation that I already explained you in the PPT. Now this is the polar plot. The same plot we got from the earlier PPT also, we got the same polar plot. So in this way we can write a code and plot a polar plot using MATLAB. Thank you all.